Hello everyone, once again let us look at the uh, meter reading procedure of this particular meter. Is an HPL electric and power limited AC 3-phase 4-wire static watt hour and VAR reactive power hour smart energy meter. So this is of type CTSM and 5, and which is in most of the cases the accuracy class of this is 0.5s, or in other words we can say that the accuracy, the percentage error of this is either 0.5% or less than 0.5. all right, which is good enough. All right, now this meter is having, or its base current is 5 ampere, and it can go to a maximum of 10 ampere, and the voltages are domestic power only, where you can directly give the voltage. All right, 240 volt 50 hertz, and it gives reading in kWh, kVh, and reactive power also. All right, so we'll see the reading one by one. All right, and before we actually go and proceed further, just to remind you that reading of this can be taken in two modes. One is the auto mode and the other is the push button mode, where you have to keep pressing the button. All right, and the parameters that are required for you is the required parameters are in auto mode only. Whatever is displayed in auto mode, which actually shows the present import values in real time, though these values are sufficient for you to build the consumer. But then sometimes you may have to go, or if you want the current month's maximum demand, then we can use the push button mode. All right, to get the current month maximum demand. All right, so first of all, let's us go to the auto mode. We'll see the readings. See, I have connected the meter like this. I have given supply to R phase and neutral. I have given because I have taken this this is a 3-phase meter, but just for study purpose I have given supply, and I'm connecting a heater also of a 400 watt heater, or a 0.4 kilowatt. All right, so the connection is like this. As I told you that the meter is the connection like this, and separate circuit also I'll be showing you in a screen. And then see, it blinks very fast because the load is quite resistive in nature, and because of that only the left LEDs you can see blinks. Okay, because most of the power that it consumes is resistive power, and because of that you will see that the power factor of this is almost unity. It's in fact unity only. If you're using motor, then the right hand side LED will also blink, which it would happen in with factories when they consume power. All right, so this is in auto mode. So first of all, this is the auto mode, the LCD screen check, and then the kWh will come. All right, this is auto mode. So for example, this time is 1713 is the present kWh reading. I mean, as of now or till now, the present energy consumption is 1713 kilowatt hour, and of course to get the actual you have to multiply this with the MF, depending on what CT ratios you are using. If you are using 50 by 5, then you have to multiply this reading with 10. I mean, depending on the CT ratio. All right, so this is the very first one is the present kWh, and the second is the R phase voltage, which we will see now. How much is the voltage? How much it is? Yes, it is 251.695, which is good enough. It keep fluctuating because this is instantaneous value. All right, it doesn't mean that it'll fix, but 251 is very high voltage though. And then since it's for study purpose only, I did not connect anything in Y phase, so the voltage here is 0. Had I connected it will show something, but then since I did not connect anything, the voltage is 0. All right, see there. And then let us wait. The next will be current. So because since I connected only in R phase, and the like I said that the heater of 450 watts, something like that, it's connected in R phase, and it goes to the neutral loop like that. So the power consumption is 1.78 into 250. You will get around 470, like that, almost half kilowatt. All right, so this is the current in R phase. And of course after this there will be current in Y phase, which I did not connect anything. It should be 0, nothing flows in Y phase. So see, there you see it is 0 ampere. All right. It is 0 ampere in Y phase, and then we'll move on and see what is the current in B phase. It's here also 0 because I did not connect anything in B phase. All right, because it's for study purpose only, and then in actual practical things it will be there. All right, and the next is the kVAH. Normally when we build the consumer, especially big consumers of connected load 50 kilowatt and above, that we build them on the basis of kVAH, and we have to take this one also. But for small consumers we don't have to take this. So like I said, this meter is is a CT operated, CT-PT operated meter. Then you have to also multiply with the MF, just like in the present case. If I'm using a CT of ratio 50/5, then the MF will be 10. So 1831 kVAH into 10, it will give you 18,000. all right, 310 kVAH, which is quite high value. So this is the kVAH. And then the next parameter after this will be your R phase power factor. How much is R phase? Because since the load is almost purely resistive, the power factor will be very close to unity. All right, so it is 0.99, which is very good. All right, okay, so it keep fluctuating. See, it's 0.99 or 1, because it's resistive. Had you got a purely resistive load, it would have been 1 only. So this is power factor Y phase. Because I did not connect any load, nothing shows in Y phase. All right, okay, the power factor in Y phase, nothing is there. And then we'll move on to B phase. Okay, B phase also, since I did not connect anything, nothing will be shown here. All right, and this is the overall power factor. It is 1. Okay, it will keep fluctuating. It's like the summation of all, the average of all. Okay, the present time, real time, it is 1. All right, it is the average of R, Y, and B phase. All right, so this is the overall power factor. And then after this is the meter time. For how many hours this meter has been on. It is 4,688 hours and 9 minutes. Okay, it has been on for this much hours, which is quite it's almost 6-7 months into service. Okay, and then we have come back to the present kWh, and then like this only it keeps rotating in the same like this. All right, so this is in auto mode. And then we'll go to the push button mode. In this case, we normally go to push button mode when we have to see the demand, because sometimes if billing of the consumer is done on manual basis, then we have to check for any excess load or something like that, and as per the Electricity Act there will be penalty if you exceed your connected load, and because of that you have to see what is the demand. All right, and that is important. Otherwise, for small consumers, you don't have to look at all these nitty-gritty of penalizing them. But for big consumers of say a connected load of 10 kilowatt and above, we normally go into the details of what is the demand also. All right, and then so we'll go to the push button mode. First of all, this screen will come, and then after this you will have this as the LCD display check, and then you will have the meter serial number. See, whatever is displayed on the screen LCD, it has to match with that of what is there in the nameplate. All right, in this case it is 5000564. It is matching. All right, now after this will be the present date. It is 12 of July 2024, and then the present time is 9:40 or 21:40 hours 44 seconds. All right, now after the time we will have BP1, that is billing parameter number 1. That is, because today is July, this is the kWh of the previous on the last day at 24 hours of the previous month. For example, this month is July, then this reading is of June. On the last day at 24 hours of June, it is 1713. all right, okay, so this is the reading. And then the billing parameter 2, this is the kWh reading for the month of May 2024, and then so on. So let's go again. It is a billing parameter 3. It is of again of the previous month. It is of April 2024. And billing parameter 4 is of March 2024. Okay, on the last day at 24 hours. And number 5 is the is for the month of Feb. All right, and then 6 is for the month of January on the last day at 24 hours. And same thing for kVH also, which is for consumers of, for example, in our state we normally build them on the basis of kVH. If the consumer is having connected load of 50 kilowatt and above, and then we build them on the basis of kVH. This is of June, and then May. All right, May, and then April. 3 is of April, and then March, and then Feb, and then January. All right, billing parameter. BP mean billing parameter. All right, now after this is your this is the demand. I will just go back a little bit. This is the 2.21 that we just saw is the demand of the previous month, the maximum demand of the previous month, which took place on the 24th of June 2024 date of maximum demand, and then at 17 hours. Okay, that means at 5 p.m. and this is the in terms of kVA, it will be 2.25. all right, this is also same, it's of the previous month. In terms of kVA, it will be this much, and the date of maximum demand is 24 light, same for kW, kilowatt, and then the time also will be 17 hours. All right, now after this is the one that you saw is import, right? It is 0.180 because this month is July, so this is the maximum demand of this month. Remember that this maximum demand is not the instantaneous value, it is actually the average that we take for 15 minutes. Whatever is the demand, the maximum demand of this, the current month, it will be the average. They take a duration of 15-minute duration. For example, if I'm using now for example, say I use a 5 kilowatt, it doesn't mean that it will be my maximum demand will be 5. In a time period of 15 minutes the maximum demand will be calculated. All right, so like this, and then same thing like at what time it took place, this maximum demand, or on what date, on 12th of July, which is today's date, and at what time. All right, at 2040. And in terms of kVA also it will come. All right, in terms of kVA also same, because it's same, kW is equal to kVA. Why? Because in this particular case my load is purely resistive, and because of that power factor is almost unity. And if that is the case, that is basic electrical engineering only, kVA will be equal to kW. all right, so it happened today at 12 and then at 2040. So okay, so these are the values that are required. This is how you navigate or you take the reading. Just like I said, you will have to take only in auto mode you will get everything, and for maximum demand you will get in push button mode. All right, otherwise rest of the thing you will get in auto mode, and you don't have to press or do anything. That's why these meter readers, when they go, they normally don't break the seal. Because why should they break? Because when they are getting everything, they're getting everything by just looking only from the meter window. They don't need to press. Or if they are not very sure of their maximum demand, or if they want to penalize them, or they want to check the demand, and in that case they can go for breaking the seal, and then they'll have to if they break the seal also, then the respective report also have to be submitted, and which is normally not the case, because they'll unnecessarily take away the time. So this much only for today's. Thank you.